Hello, welcome to episode 31 of Motion Along Inclined Plane under Mechanics Dynamic series that we are doing. So in this episode, we have a particle is released from rest at a point A on a rough plane inclined at an angle of tan inverse of 4 on 3 to the what do you call it, to the horizontal. We are to find the coefficient of friction between the particle and the plane is given as 1/3. We are to find the speed of the particle when it passes through the point B, where AB is of a length of 8 meters. We are to do that to one decimal place and find the time taken in going from point A to point B to 2 decimal places. Let's see if we can make a rough sketch of that inclined plane. Okay, so if we have this, let's see how we can do this. This is going to be the weight of the body acting downward, but bear in mind the surface is a rough surface. So we can get the concept from episode 24 where we started this particular series. So if it is rough, it means there is going to be a frictional force acting on the surface, right? That is going to be the F. Then this is going to be the normal reaction. And here we can, looking at the first part of the question, there is going to be a particular force which is parallel to the surface. This force is moving in this direction as the friction is moving in order to hold. So that is the force holding the body from sliding. If the body begin to move down, then the frictional force begin to move up. If the body begin to move up, frictional force begin to move down. So this is what we are going to have. But already the force of gravity acting on the body is in the downward movement, which is a mg sine what? Theta. So if the body is going to, let's say we have angle theta, I can easily move this down. So to have this. This angle of inclination is not provided, but we have a hint that tan inverse of this. So if I'm saying tan inverse, it means that if I have the angle, this angle theta is equals to tan inverse of 4 on what? 3. And I am looking for the angle theta. It is what I'll get. That will be the angle in there. But we are not actually making use of tan. If all the formulas we have done so far, we either make use of sine or what? Cos. So we need to find that value. So that simply means that dividing both sides by tan, right? Okay, multiplying both sides by tan will give you tan theta equals to 4 on what? 3. If I multiply both sides, since this is 1 over tan, if you multiply by the tan, you have this. So this, I'm not going to show all. You can see that this is the opposite side. This is going to be adjacent. That means that 2 is opposite over adjacent. So 4, 3. I need to find this using the value of what? Trigonometry. Because of space. Right now I don't have enough space, so I will be finding that without making it part of the calculation. So if you have this being 4, 3, this being x, we can actually use x squared equals to 4 squared plus what? 3 squared. That means the root of 16 plus 9, the root of 25, making it what? 5. So this here is going to be 5. If that is 5, the angle theta will be here. What do I need? I need the sine of that angle. So I can say that the sine theta is going to be opposite side divided by hypotenuse. So 5. So here I have sine theta equals to 4 divided by 5. How about cos theta? Cos is k, right? The adjacent hypotenuse as in 3 divided by what? 5. I am going to make use of this since I don't have enough space. Okay, so this is what we have. All right. Remember, the body is moving down with an acceleration. we are going to use that. And based on the premise of episode 24 again, I am not going to delve into how we derive the acceleration. I am only going to say that our acceleration is going to be the value of gravity multiplied by the sine of the angle minus coefficient of what? Friction times the cos of what? That very angle. This is how we derive that value in episode 24. You can go there and check that. So that means 10 is multiplying the sine of what is that? Okay, let me just replace it directly. Sine theta. Sine theta is 4 on 3, no, on 5, right? Minus, this is coefficient of friction, which is 1 on 3 times the cos theta, which is also going to be 3 on what? 5. Right here, this cancel this. We have 1 out of, so this is 10. 1 out of 5 times, what is it going to be? This is going to be 1 minus 1, 3 out of 4, 5. This go here 2, that give us 6 meter per second square. The acceleration is now known. We also know of the distance travel from A to B. That is when the body is right away, either here, moving down. The distance from the A to where the B is giving us what? 8. So I can also say that where the distance is 8 what? Meters. All right. What again do I need? The speed. In this case, velocity. We are looking for the velocity. As the body is at A, it possesses initial velocity of what? 0, right? So I can also say that initial velocity will be 0 meter per what? Seconds. What is next? Which other formulas can we use? Let's say v squared equals to u plus, now that I know acceleration, I'm going to use the a instead of using all these formula in place of that. So I use a as 2a what? S, where final velocity we are looking for, right? The speed of the particle when it passes. So we are looking for that final velocity, initial velocity of 0, acceleration of 6, distance is going to be that. Let's do substitution. So what is it going to be? Let's move square of this equals to 0 plus 2 times 6 times what? 8. I guess this is 12. 12 times 8 will be 96, right? So v squared will become 96. We need a v, so we find the root of that. Let's clear this part, but let's take note of all information that is being given. I think we have seen all the information. We have this. The next is to find time. So we can clear here and continue. So right from here, we can see that our velocity will now be equals to the root of what? 96. 9.798, but we are looking for the speed, right? So therefore, the speed at B is going to be 9.1 decimal place, right? 8 meter per second. So let's go for the second one. So this is the speed at which it will get to B, not necessarily the bottom. We don't know where the B is. The B is just 8 meters away from the starting point. All right. What next do we need? We are looking for the time taken between A and B. So the time taken, final velocity is known. Initial is known as 0. The acceleration is known. We can find time easily. So there are 2 or 3 ways we can find time. I will use one of them. Let's say from V equals to U plus AT, where this is 9.798, this is 0, acceleration is 6, then the time is what you're looking for. Then that becomes 9.798 equals to 60. Divide both sides by the 6. And it will be giving you 1.633. And therefore, the time taken from point A to point B is going to be 1.63. This is to 2 decimal places. The first one is to 1 decimal places. We can also use a different approach, as in the distance equals to the average velocity times time. Half of v plus t divided by 2 times time. You still come back to 1.63. I believe you get the concept. So if the premise of this is based on episode 24, go in there and understand the movement of bodies down the plane or up the plane using the force of what? Gravity. All right, like, share, comment, subscribe, and come back for more.